Hello.
Hi, how are you?
All right, and yourself,
I'm
Ludi.
good. I'm Luni. That's Lou.
Hello.
And we are here. How are you guys? I hope you guys are doing good. Welcome to Life Sciences. What's happening today?
Well, we decided to do some experiments. So what do you think, Luni? We need to start looking at the beginning part of life. Huh? What do you think?
Yeah,
where
no.
life actually starts.
That's cool. We always have life problems, so it's nice to know where it all started.
That's it. Or where we get our energy from. That's the main thing.
Yes. Mindsetters, don't forget to hit us up on Facebook and on Twitter at Learn Extra. Download the show notes, the videos, the schedules on Learn.
Sorry?
Download the show notes, the videos, the schedules on learn.mindset.co.za. I will post it on the Facebook page, whereas now I'm here, but I'll post it when I'm that side.
When she's that
On
side. When she leaves me.
Yes, and we have a view and download option, guys. So remember, if you have a feature phone, you can view the notes. If you have a smartphone, you can download.
I agree. Now, Luni, remember I gave Mindset that challenge, the random act of kindness, the rack nomination.
Yes,
Can you
I remember. Yes.
I've
I
just
was
seen
here.
it.
Yes, I was here.
I've just seen what Mindset did. I was almost in tears. Hey,
Aww.
Mindset went to a school and gave them shoes, and you should have seen the people's face. And so it's amazing. I've never seen something so nice.
We try.
Oh, that is so gorgeous. Now,
Yes. It doesn't end there, hey.
no, I want to know what you guys are going to do out there.
Yes.
Hey, Mindset has come. Let's see what you can do. Let me hear about helping other people out with school shoes. I mean, because without an education, we're going nowhere, hey? And that touched me. And just a pair of shoes just did so much, hey?
Yes.
Well, at least I must breathe now.
Emotional.
Emotional.
What's going on?
But we do love you, Lily, so it's fine.
yes.
Right, now, back to studying. Right, now, what I've done is I'm doing some photosynthesis experiments, because without photosynthesis, we as humans can't live. You do know that, Luni, that
Yes, I know
if
that.
plants die, that's it for us.
Yeah,
we
no
can't survive.
oxygen.
So now I need to find out how they make their food and what is photosynthesis, how to test for photosynthesis. Okay, now the first thing I like testing for is normally the starch test, but I need to get the water boiling there a bit. So I've got a leaf, right, that's been in the sun, right, and I want to see if it photosynthesizes. So I just want you to remember one thing. I'm going to take this leaf and I'm just going to put it into water. So let me move this away.
Should I go?
No, you can if you want. Do you want to stay here by me, or do you want to
Do
go?
you need me here?
You need to get the information, hey, Luni. They need to get posted.
Yes.
Okay, so I'm going to send Luni. So it's just
bye.
me and you now. Just me and
No,
you.
can I take my chocolate?
You can take whatever you want, my sweetie. Right, now, what I'm going to do is I'm just going to take this and I'm going to just pop it into water there for a second. Right, well, not really a second. I'm going to put it in there. I just want you to remember, just plain water, nothing else. And I'm boiling it there so it can get nice and hot. Right, let's just open it up a bit. There we go. And let that do its job. Right? While that's doing that, I'm going to give you another experiment. Now, the experiment I want to do first is an experiment that we test what is produced when photosynthesis takes place. Because there's a couple of things. First, we have a look at if light is needed for photosynthesis, okay? And then we do a test where we take a leaf and we cover a part of it and we put into a dark room, and and then we do a thing called a starch test. Now, what I'm going to do today with this leaf over here is a starch test, okay? Until then, I'm going to try another one. So the first one is checking if light helps with photosynthesis, okay? The second one that we look at, right, is what does a plant produce during photosynthesis, right? And that's another one I'm going to do. And then there's another one, does photosynthesis use carbon dioxide? So we're not going to look at that one, but I brought two so we can look at them, right? When I get back to the board just now, we'll look at those. Now, what I've done is I cheated slightly, because this plant in here, if you have a look carefully and if you can have a good look, there's a plant inside there, and that plant is a water plant, right? So that lives underwater and it photosynthesizes there. And if you have a look carefully at, let me do this, at over here, we have a funnel. Now, what I need for this experiment is very simple. Okay, I need a beaker, I need some water, I need a plant that lives in water, okay, and I need a test tube. Easy, nice and easy. And what I've done is, you fill this test tube with water. So you take a test tube and you fill it up to the brim with water, right? Then you cover it and you put it inside the water. So this whole test tube is filled upside down in water, right? Then you put it over there. Now what will happen is, if this plant, whatever this plant produces, right, oxygen, carbon dioxide, or whatever it is going to go up into this test tube and it's going to get rid of the water that's inside it. Okay, so that's what it does. Through displacement, it moves the water out of the way so it's got place to go, right? So that's what's happened. But it actually takes quite a while, okay? And if you have a look carefully, there is air bubbles. Can you see there's air bubbles on the inside on that plant, okay? So it's producing the oxygen or carbon dioxide, whichever it is, and it bubbles up all the way into this, and now I've captured it in here, right? So we need to test what type of gas is in here, okay? Now, it's very, very important to understand. To test for oxygen, we use a glowing splint. In other words, I'm going to light this. It's going to go nice and red, and once it's red, I'm going to put it inside here, and it should glow a lot more, right? But I know I sent Looney back, and it's never a good thing to send Looney back too quickly.
Why?
Because I need you to help me here.
Let me post the
She's
notes.
going to post it. Okay, so let's carry on. If we have a look here, I want to see how fast this is going. I know it's nice and hot, and I'm going to stir it. You'll notice that the leaf's becoming very soft, right? Why do you think I would boil this? Okay, I've got to put it into hot water. Okay, you've got to boil it in hot water. Main reason is, when you boil a leaf, you're doing a thing called you denaturing it. I'm just going to put this aside for a few seconds. You denature the leaf. In other words, you are breaking down the bonds, the what do you call those? The cell walls, for instance, right? So you boil it so it gets nice and hot, destroys the bonds, and then we're going to take it out. The next step we're going to do, I'm going to pull this out. Right, let's do it in here, okay? I'm going to take this, and I'm going to use this stuff, methylated spirits. Okay, normally you use alcohol, not the alcohol you buy from the shops. I'm talking about ethanol, methanol, all those type of things, right? And, oh, I can't use this because I need to put it into there. So I'm going to put it back into this test tube. I'm going to pour it in there. Hopefully I don't spill too much. Okay, there it is. Okay, now the whole point of this is, this stuff's very, very important, because what we do with this at the end is we actually need to get rid of the chlorophyll, right? So that green stuff that makes the leaf green, right? That stuff that's found in the leaf, there it is. I need to get rid of it, because how am I going to see? The whole point of a leaf, what it does is it takes its food and it stores it as starch. And when it's got starch, okay, that's put aside. Now we need to do the test for starch. If this is test positive for starch, it means it's made food through photosynthesis. Right. Looney, how are we doing there, girl? Perfect. Okay, so don't forget this. So I've done two experiments at the same time. Right, so here we go. Now, what I want you to do, Looney, very, very carefully. Okay, we're going to remove this, but I need you to do it like this.
Remove this?
Remove that, yeah. But what I need you to do, watch carefully. Okay, it's inside the beaker. Okay, I need you to take it, put your fingers over so you block it as quick as possible, so you can pick it up. You can pick it up and block it.
Okay.
And then turn it upside down and hold it like that for me. Okay. You need to do that quickly.
Put my hand inside.
You can, remember, no, you don't have to put your hand inside. Just pull it up and block it immediately as quick as you can. Block it tight. That's it. Okay, now, very nice. Okay, now I need to light this. I'm going to use.
But there's nothing.
Hey, that's perfect. You hold it. That's nothing. That's what we want. Let's see if we can get this going. There we go. Let's get it nice and
still close
glowing.
this part.
Close the part. That's it. You'll notice I'm making it nice and hot, getting it nice and red. Okay? Now, you need to watch very carefully when I bring it closer. So I'm going to move the water out the way. Looney, you need to bring it right over here so everybody can see. And when she lets go, watch the glowing. 1, 2, 3, let go. See how red it's going? Look how much lighter it's going. Okay? Let's see. I'll see if I can, during the break, get some more, because I have got another one in the back there. But what happens is it actually goes nice and red, like this. Did you see how red it went when it went in here? Now look at the difference. If I put it in without that redness, see if it goes. Come on. Watch now. Look, it doesn't even go very red. See how it does? It's too much carbon dioxide. Can you remember how red it went when we put it in?
Very
It went nice and red. That is oxygen, because oxygen makes a glowing splint go nice and light. Right. Thanks, Lily.
Thank you.
So that's what we did with that experiment. Nice and easy. Now, this water, come on, you need to boil. Come on. Okay, now, while we're busy on this, photosynthesis. I'm going to go to the board, let that boil a little bit, and then we're going to come back in a few seconds. Right, okay, so here we are. We're going to do photosynthesis, okay? I'm going to start off with what are we going to learn this lesson? Come on, let's get some pens going here and get some life and fun into it. Okay, we're going to review the process of photosynthesis, so we're just going to have a look what's going on. Right, then we're going to have a look at studying of the starch test in leaves. Now, very important, we use, excuse me, starch test in quite a few things, which I've done. It's very important. That's one of the experiments they always ask. Right, then I'm going to have a look at the study of various practicals and how to answer them. The main key, how to answer them. And then let's have a look at the next one. We're going to look at how to complete a practical write-up. Okay, because a lot of people forget how to do that. Okay, it's very important to be able to understand how it is. Now, that's the stuff I've got for you. I've also got questions. The first one I want you to have a look at, of course, is the challenge question. Now, the challenge question is, how does the light phase in photosynthesis differ, so not the same, differ from the dark phase? Okay, nice and easy and simple. It's not a difficult question. Hey, I can already help you with one. If you look at it, light phase, dark phase. Luni, can you remember difference between light phase? Just simple.
We did that
last week.
Yes.
Okay. So what do you think it is? Light phase and dark phase. One uses
light.
And the other one?
No light.
See, she's brilliant. What would I do without her? Right. Okay. If you have a look back at that experiment, you will notice that the water's starting to boil, which is a very, very good sign. Right. Now, let's have a look at this process quickly. Right. Just again, while it's boiling, I want to make sure that while that's boiling, right, we're going to do a little bit of work. And then after the break, quickly, we'll go through that experiment again. Right. Now, remember, when it comes to photosynthesis, we use water, which we get from the roots, right? We take carbon dioxide, which we take through the stomata. We use the light, right? And of course, in the leaves, it's green. It's got chlorophyll, which is found in the chloroplasts, which is chlorophyll. And we use enzymes, right, to make certain things. It's called glucose and oxygen. Now, you need to know it this way, and you need to know the chemical makeup of it. Right, so water, H2O, which is 6 water molecules. You need 6 carbon dioxide molecules to make 1 glucose, which is C6H12O6 molecules, and 6 oxygen molecules. Right, very important. That's one of the most important things that you need to know. Okay, now remember, the process of photosynthesis, right, is to take light and water and to produce a substance, okay, to produce, take light energy, which is from the sun, and change it into chemical energy. So let's have a look at it. It's whereby light is converted from, light energy is changed into chemical energy, right? The sun is changed from changed into chemical energy, which we change it into a sugar, right? There it is, a sugar and other organic compounds. For example, starch, which is what we're looking for while the stuff's going, right? So we're changing it into that, right? The process consists of 2 things, the light phase and the dark phase, okay? Very important. Use 2 phases, and you always got to remember it. Okay, and in those 2 phases, in the beginning part, we need the following things. We need water, right, and carbon dioxide. The nice thing about it is is us humans, we breathe out a lot of carbon dioxide. So the plants are cool. The problem is, what do we cut down, Looney? What are we cutting down?
What?
Well, if I'm breathing out carbon dioxide, right, what am I cutting down all the time? It's big things, and they got these trees. That's my
Trees.
girl. Trees.
I was just whispering just to make sure if you were on the same page.
You're on the same page. You're getting good. We cut down the trees, and if we cut down the trees, how far are we going to go? Right? We're not producing as much oxygen. Okay? So we're cutting down all the trees. We need to stop that because photosynthesis is one of the most important things that's coming around. Right? Without that, we're not going to go anywhere. Okay. So what I think we need to do, I think we need to go for a break. While you're on that break, let me see if I can get some more oxygen. Okay, let me get some oxygen into a thing for you and try and light it so you can see it again. Can't promise it's going to work very well, but let's see what we can do. Right, hey Looney?
All right. Mindsetters, if you want to win yourself one of these awesome calculators from Casio, all you need to do is complete the test yourself section from the show notes. I have posted everything on Facebook, so you've got all the details on Facebook. Casio calculator. It's very nice, very awesome with funky features and everything. All you need for your schoolwork, everything on this calculator. So guys, make sure you fill in the test yourself questions. Fill in the entry form. I will post everything on our Facebook page, and then we'll see you after the break. Welcome back, Mindsetters. You almost saw miracles happen on this show. I was about to teach life sciences because our teacher, he just disappeared. He went MIA on us. We couldn't find him. He just disappeared. I'm exposing you.
No, but that's good. But what am I doing? I'm trying to help.
But you can't just
I
disappear.
ran. I had to go back to go find all this stuff. Right? Gee. Now look, there's
Welcome
more
back
oxygen.
from life.
So you must know. So let me see if I can quickly do that one again for you, because this is boiling nicely. And straight after this, I'm going to show you how that works. Okay, come on. Let's get the glowing splint going here. Looney, how about you come and hold the glowing splint this time?
Glowing splint.
The glowing splint.
Splint. Oh.
Okay, so hold that there. Let's get some fire going to that. Right.
Then you want it to burn.
Yeah.
Oh, you have water. I don't.
Okay, now you'll notice I've got a bit of water in there. Okay, that means I didn't go all the way. Okay, now Looney, blow that out.
Fire.
Now you see it's not that red. Look carefully at the red and stick it all the way in, hey Looney.
Okay.
Look carefully at the red.
But
One,
not in the water.
2, 3, go.
Wow, it's
Did
burning.
you see that? That is...
burning
No,
even.
no, all the way to there, it's fine.
Okay.
Did you see how that burned? That is oxygen.
Oxygen.
Now that's what that thing does. Right, it shows you that photosynthesis makes oxygen. Hey, how nice was that?
Awesome.
Better. Right, okay, cool. Now let's have a look at what I've got here so far. Okay, now what I have here, just hopefully, to cool that down. This thing's been boiling quite nicely. Now, what I've done is I've denatured all the cells, right, so that we can break them off. Okay, now I'm going to take this stuff, which is methylated spirits, and methylated spirits has got what in it?
No. Paraffin?
It starts with an L.
Oh,
Yeah. L.
liquid.
Co. L.
Alcohol.
Clever girl. You see,
Alcohol.
no help needed for you.
No, yeah.
Okay, so I'm going to take this and I'm going to stick this leaf
No.
into the alcohol. Ah, there
No,
it goes.
can I please just share this? I'm sorry, like people doing my ear. Does alcohol start with an L?
Yes.
Alcohol.
Yes.
There where you come from.
Yes. L. Yep. Guess where I'm coming from? It says L and then co. I'm not spelling it properly. It's L. It starts with an L.
Oh, as in A-L. Okay,
Yes.
okay, we can forgive you. We
What did you think I was saying? With an
L.
A? No.
L as in L.
As in A.
Alpha Llewellyn.
L as in A-L.
Okay, let's leave it. It's fine.
Woman. Right. Now, watch carefully. What happens to alcohol if I put fire to it?
Can I not be here when this happens?
See, she doesn't want to be here. So,
Yeah.
first of all, we got to be clever and we got to use something that holds the test tube, right? Because we don't want to damage old gorgeous Looney here. Second of all, I don't take alcohol near a flame because what's going to happen?
It's gonna.
Right. Now, let me give you a little bit of science here. Water has a boiling point of 100. and alcohol has a lot less. So what we do, watch carefully, is we stick the alcohol in the water and look what happens. Just have a good look at what happens. No, don't worry.
No, the thing is, you see, people are worried about me. I'm also worried about myself. Don't know what's going to happen. What if it explodes?
This here, well, I'm not very worried about that. This here, the alcohol has a lower boiling point. So because I've put it into boiling water, look carefully at what happens to the alcohol. If you can look nice and closely, the alcohol starts to boil, right? Now, why are we putting it in alcohol? Why do you think we put it in alcohol? Very, very important reason. We put it in alcohol for a good reason. Remember what color that leaf was when I took it out of the water? What color was it?
When you took it out,
Yeah.
it was a faded green.
It was a faded green. Very nice. And this water's got a slight green tinge to it. But I need to see everything. Have a look. What's happening to the alcohol there, Looney?
It's boiling.
It's boiling. Now the nice
But
thing
what-
about
the
this is,
colour.
the nice thing is I can turn this whole thing off and it'll still boil because the water is that hot.
Did you turn it off?
Yeah. No,
No.
there's still gas in the pipe. Looney.
Oh,
Stick with me here, girl. I'll make you famous.
Because it was this side when it was off, but no, it's fine. Make me famous.
Now-
Oh, that's off.
Now watch. Still boiling quite nicely. What color what color was the methylated
just-
spirits?
But now why the
Oh,
color's
look at
changing?
the colors changed.
Yeah.
So what do you think is happening? What am I pulling out of that leaf?
The
Yeah.
chlorophyll.
Clever girl. She's brilliant. So I'm taking the green out of the leaf. Look at that.
Oh, cool.
Look how the color is
And
changed.
then now the tube is purple a bit.
Yeah.
Okay, I can see that.
Okay, now look at that. Look at the different color. Hey,
That's
Looney?
cool.
That's cool, hey?
Yeah.
Now that we've done that, okay, what I want to do is I need to remove that leaf. Now remember the alcohol is what? Hot.
Hot.
What does boiling mean?
Hot.
It's hot. Now, I'm going to take it out. Come on. And it's nice and hard. Look at the color of the leaf now.
Oh, yeah.
Come here. No one asked you to go back in there. Come on. Oh, I'm going to cheat.
I'm just gonna pour. Oh, now it's green.
Ha, look at that.
Looks like cabbage.
Looks like cabbage. Now remember the difference. Let just show you slightly. Look at the difference between the two, right? So I've removed the chlorophyll. Now, feel the leaf. It's quite hard. It's not as soft as it was.
Oh,
huh?
yeah.
Okay, and smell your hands. You can smell the alcohol. Yeah. Okay, it's hard. It's very hard, and I'm messing all over the place, but I really don't mind. So what I'm going to do is I'm going to put it in there, okay? Because it's still hot. Look how it opens up. Okay, Looney, don't worry. Alcohol's not going to kill you. It's not going to kill you. It's actually very good for you.
My
sweetie
fingers
pie.
are feeling very funny.
Oh, now you're feeling better, sweetie pie. Right? So now look. It's nice and relaxed, soft again, and hot.
Sorry.
Very hot. Right? And open it up. Can you remember the color of the leaf the first time you saw it?
Yeah, it looked like cabbage.
It looked like
It was
cabbage.
very
Now
light.
look at it.
It's
Look
getting
what
a-
color it is now.
It's color.
Hey, where's the is it still green?
Uh-uh.
If I have a look at this, doesn't this look like a leaf that has just fallen off the tree in autumn?
Oh, yes.
All the green's out of it. So that's exactly what the alcohol does. It removes the chlorophyll. So all the chloroplast, all the chlorophyll is in there. Okay, now, if we have a look at it.
Do you still need me?
No, we don't need it. But I always need you, Looney.
No, like,
I get it.
I'm
Right,
there.
I've got this stuff called iodine, right? Now, what happens with iodine is if this leaf does not have starch, it's going to stay like a reddish color, right? But the minute starch is present, it goes a blue-black, a dark blue-black color, right? So this is how we're going to test it, okay? I'm going to open it, and I need to, I made sure I went and bought new ones just to make sure it's 100% right for you, right? And this is a dropper, okay? So take the dropper, suck up a bit of, I don't want too much, right? And I'm going to drop it. I will show you. Okay, don't go too far. That's it. You will see exactly where it photosynthesized and where it didn't. Which is the nicest thing out because I made sure that this leaf was half in the shade. Hey, there we go. Now, put this away. Just have a good look. Have a look at that. You will notice that where it is a very dark color, that's where photosynthesis was taking place. Where it was a very light color, there's not much. It means that there's not much starch there, right? You know that bread and all of that is starch? So have a look. Look how dark it is, and look here. Look at this. Nothing. Look here. Nothing. This piece here is where photosynthesized. Hey, how cool is that? Now that is your starch test. Just a quick word. Don't get it on yourself like I just did, because it will stain for weeks and you're not going to be a happy person. Right. Okay. Let's do some questions. I think we need to. Well, not questions. Let's carry on a bit and see how far we get. Right. Okay. Now, let's get back to the spot. We did the whole part of photosynthesis, right? We're having a look at it. Now we need to have a look at what we need. And I'm going to run through this very quickly because you've seen me do the experiment. Okay. First of all, with this is the starch test, exactly what I said. We need a beaker. Where is it? We need a beaker. We need a tripod stand, wire gauze, which you saw. Okay, if you want me to have a look at it, I can go back and look. Just let me know. A Bunsen burner or a spirit burner. Okay, test tube. We put the alcohol in the into the test tube, right? Methylated spirits or ethanol, plain and simple, right? Forceps, which is that tweezer thingy that we needed. Okay, there it is. A white towel, I just put it up on top of me, white towel, because you can see it quite nice and clearly, right? Iodine solution and a dropper. Easy, simple. Okay, there it is. That's the exact same experiment I showed you over there. I took the leaf, I boiled it in water, right? I took it out of the water, I put it into alcohol, into a test tube, right? Then I rinsed it back in the water, I put it down, and I put iodine drops on it. Easy, simple. Right, that's a nice and easy one to go through. Next one. Okay, the next one I want to have a look at is to remove a leaf from a healthy growing plant. See what the difference is, starch test. Okay, this one is exactly the same. What this is saying, I want to get to the question so you must understand where I'm coming from, right? This one's saying when a plant, part of the leaves don't go through photosynthesis, then you're going to get that different colors as you saw, right? Now this one was in semi-shade. It was in quite a bit of shade actually, and it's been raining, right? And it's overcast. It's not getting as much photosynthesis. It's not photosynthesizing as much, if you get where I'm coming from. Hey Luni, you with me, girl? Mm-hmm. Mm-hmm. She's good at that. Mm-hmm. Yeah, no, right? No. So what they're trying to do is when they do all of this experiment, right? At the end, you're not going to get a blue-black color. You're going to get blue-black here and there, and you're going to get an open piece. Right. Now, that's a very important thing. If I had to look at the practicals that we're looking at, that wasn't a practical. That there was the starch test. Okay, now the practical, okay, is very simple. This one is if light is necessary for photosynthesis. Okay, so what they do, same thing, method, this is the difference. They want you to cut a shape out of a strip of foil, tin foil, and stick it on the plant. Once it's stuck on that plant, that piece or under the leaf is not going to photosynthesize, which means it's not going to have that blue-black color. So you stick it on the plant, the rest of the plant will go through photosynthesis, right? And that part where the foil is not going to photosynthesize. How do we test that? Starch test. Do you get where I'm coming from? Okay, so you first need to, the most important thing is you take a strip of foil and put it on, right? Any shape you want, it looks quite nice. And trust me, it's a lot of fun. Try it out. And you can do this at home. It's a very easy thing. Just watch out for the fire, hey? It's never a good thing. Those things are very dangerous. Hey, Luni.
Yes.
Yes, yes. Mm-hmm.
Fires are dangerous. Come on.
Fires are see, she's with me. Practical 2, very nice one. To determine whether chlorophyll is necessary for photosynthesis. Okay, what do we require in this? Okay, we need to leave a plant in a dark room for 48 hours. In other words, 2 days, right? The reason why we put it in there is to stop it from photosynthesizing. Okay, there's no light, which means the leaves are still going to survive, but they're going to be dark. They're not going to be a very happy leaf, right? Then we're going to take it out, and the minute we put it in there, okay, we take a leaf from it and we do a normal starch test. You'll see that there's no starch in it. Then we put it in the light for a while and test a different leaf, but from that plant, and you will see that starch is present. Okay, so that is the next simple experiment. Okay, the results, as you will see, there will be starch present where the green parts of the plant is. Okay, so those leaves are not going to be as green when you take them out of the dark room. As soon as you put them in the sun, they're going to start going a little bit more green. Right. Okay, cool. If we have a look at the next one. Okay, this one's also a nice one. To test whether carbon dioxide, right, is necessary for photosynthesis. In other words, does it use carbon dioxide to do photosynthesis? Okay, here we go. You're going to put 2-pot plants in a dark room. When you take them out, you're going to put in 2 types of liquids, one in the one in the other, and you're going to put a bag over it so it doesn't escape. The first plant you're going to put here is sodium hydroxide, or NaOH, right? Sodium hydroxide. The second one we can put in is sodium hydrogen carbonate solution, or what was that word that they use? Sodium dioxide, I think it was, or sodium, I'll find out the name. Okay, I'm sure it's sodium dioxide. Remember, I do life science here, hey? Right, so sodium hydrogen carbonate, right? Nice and easy. So this one here is very important, and this one here is very important. And you will notice that one of the two, I'm not going to ask you, I want to ask you, you need to tell me, right? Which one of the two produces carbon dioxide, and which one out of the two decreases carbon dioxide? Right, that's what I want. Hey, Looney, let's get some questions going there.
Yes.
Okay, definitely, right? And what you're going to find out, I want to see if it is there. Okay, what you're going to find out is the one plant is not going to photosynthesize. All of these things, all of the experiments that you do with this, you need to end with a specific process. And that process is, come Looney, what's that process? Starch test.
Starch test.
You always end with a?
Starch test.
Always. Why? Because what is starch? It's the storage of glucose for plants. Right. So we always end with a starch test. So, same thing. Now, please don't forget. I want that answer. The difference, or which one? Which one between the two, sodium hydrogen carbonate or sodium hydroxide solution, which one produces, not produces, let me put this right. Which one increases the amount of carbon dioxide and which one decreases the amount of carbon dioxide? I want an answer. Send it to Looney. Hey, Looney? Okay, cool. Now, while we on that subject, Looney, do you know something about a multiple choice question?
It's when you have options. You have
Options.
questions and then you have options.
And on
But
the
they're
page
always
we've got
similar. They are
they're always similar.
always similar.
Always similar. I must remember
Always.
that. And the nice thing about it is when you do it, there's always satisfaction at the end with us, hey? With the multiple choice questions. Right, so we're happy with this experiment. Okay, I'm going to look at the next one. This is the same one, isn't it? Determine whether carbon dioxide is necessary for photosynthesis. Okay, plants that had, oh no, I don't want to do that. That is very bad. That's very bad. I almost gave you the answer there, didn't I?
Hey.
I almost gave you the answer, and I forgot about that. It's very simple to tell you, okay? Well, hopefully you got it right. So, Looney, has people sent back the answer already?
No.
Nobody yet.
The thing is, it's slow, so maybe they
so
have.
they have, but it's, okay, so then,
Yes.
if you have, let me go through it again. Watch carefully. Okay, this is the answer. This is what I'm looking for. Right. The plant that has sodium hydroxide with it in the plastic bag. So remember I said you put it on and you put a plastic bag around it so that it keeps it in there, will produce less starch. So the sodium hydroxide, right, gets rid of the carbon dioxide. Takes it away. Now, if we have a look at it, the plant with the sodium hydrogen carbonate, that there produces carbon dioxide, right? It melts away and it produces carbon dioxide, and the plant uses the carbon dioxide and goes through photosynthesis. If it goes through photosynthesis, it's going to store the starch, right? How are we going to end the experiment, Looney? How will we end the experiment with this one? You know what? When we say things
What?
together.
No, what are you talking about?
Well,
With
we
the
have
starch.
the starch what?
The starch test.
There we go, starch test. We
man.
always end with
The starch test.
good girl. We can teach her lots between the two of us. Right. So if I have a look at it, determine whether oxygen is present. You saw the experiment, right? Very simple. Test tube, glowing splint into the test tube. There we go. You will notice that oxygen is produced at the end of it. Okay? All of this stuff is very, very important. Very important for you. Right. Let's have a look at the next one. Navigating questions. Well, what I want to do, all this is available to them. Hey, Looney. All of this is available to them. So I want to ask you guys something. Okay? When it comes to these practicals, you're going to start with different things. Right. They're going to ask you things like your dependent, your independent variables. Right? They're going to ask you, for example, what is state the hypothesis. Okay? The hypothesis is very important. A hypothesis is a fact. Very important. Don't come, this might happen, right? Or I think that will happen. For example, plants might produce oxygen during photosynthesis. It's very simple. You want to give a hypothesis, you say this. This is how you say it. Plants will produce oxygen during photosynthesis. You're not asking, you're not roundabout. Fact, that will happen. Right. So anything you do when it comes to a hypothesis question, you got to say, this is perfect, to the T, 100%. This is fact, nothing's going to change. Whether you're wrong or right doesn't matter. Okay? You are stating a fact. You might at the end say, well, the hypothesis I put down was wrong, but you still put a fact down. Hey, Looney. Good. What do you think? Do you need a break?
Yes, please.
I need Looney to liven up here a bit.
Yes.
So what I'm going to do is I'm going to feed her with some glucose as much as possible. Let's see if she comes back with a smile on her face.
Yes, I'm always smiling. What are you talking about?
You're like in a book today.
No,
I miss you.
I'm concentrating here, doing huge things. Mindset is
That's better.
Mindset is it's time for a break, so don't go anywhere, guys. We'll see you straight after this. Welcome back, Mindsetters, from that break. So if you didn't know, I'm sure I did this, but I didn't. Apparently.
Why do you think I mentioned it?
Oh my gosh. If you didn't know it, guys, we are giving away Casio calculators for every show. So for you guys, all you need to do is fill in the test yourself questions for this competition, and then there's an entry form. It will be posted on our Facebook page. Had a few glitches with the entry form there, but I'll post it on the Facebook page, guys. And you stand a chance to win this. Are you happy now?
Sort of.
Okay, what's the problem?
Multiple choice questions.
What about them?
That's how we're going to win this Cassia, right?
That's how, okay.
That's how we're going to win this Cassia. But you know what? Let's forgive her this time. Because
please, guys.
She is pretty.
Yeah, thanks.
She's pretty, so we can forgive her this time.
I'm just working on my prettiness today, like, yeah.
She's had a long day, and I understand it. It's not a good excuse, but I understand it. Right, now, see, at least we can make her smile. I made sure she had chocolate during the break.
Such nice chocolate.
Now, the question was, the challenge question was, okay, here we go. How does, let me get some pens going here. How does, ooh, I don't like that color. How does the light phase in photosynthesis differ from the dark phase in photosynthesis? Now, Looney, did anybody give an answer to that?
I can give you that one in just a few seconds.
1, 2, 3, 4. How does the light phase of photosynthesis differ from the dark phase? Okay, what do you have there for me?
No, I'm trying to. Does it have something to do with Ooh,
no, it's got nothing to do with ooh.
With sodium.
With sodium.
NaOH, the decrease the amount of photosynthesis, while NaHCO3 increases the rate of no.
That was the question before. We answered that. That was very nice that you guys sent that.
Oh,
now I need the challenge question.
Challenge question.
Yes, the challenge. Now the finger goes up.
Hold
we are
that
ready.
thought.
Let me hear.
Oh, 49 comments. Okay, we have it.
49 comments.
The light phase, this is from Chloroplasts. The light phase in grana and dark phase in stroma.
Very nice. That's brilliant.
Oh,
Okay, so that's one thing. Yes.
Is that what you're
That
looking
is on track.
Okay.
Who was that?
Chloroplasts.
Lovely. But nice.
You can't pronounce the name.
No, you're right. There's no ways I'm trying.
Okay, and then this is from Tabeleng. Light phase occurs when there is light, and dark phase occurs when it's dark.
Whoa. Hold on, brakes. First part, light phase comes when there is light. Dark phase does not need light.
Okay.
Okay, it's a big difference between when there is no light. Okay, because the dark phase happens during the day as well. Hey? Okay, let's hear.
This one is from Kutlwano. Light phase or dependent phase needs light to occur. Dark phase can occur with either light or no light because it's simply independent.
100%.
Ooh, this one is so long.
Let's hear. Because if you have a look at it, let me show you the answer. Hey,
Okay.
look at this.
Okay, it's quite long. Okay.
Huh?
They're on track,
Ooh,
these
it's a
people.
big one, this.
Okay. Let me read Mukovi's one. Light phase, also known as Hill reaction, takes place using sun's energy. It uses photons to break the water molecules to release O2, oxygen. Also, the reducing factors NADPH are formed in the light reaction. The reducing factors are used in the dark reaction, biosynthetic phase, to reduce the CO2 molecule into glucose.
Nice.
Is that what you're looking for? Is that fine? Let's
That
read
was
another one.
You used big words there.
Yo, yeah.
Very nice. Now, what I did like is that the light is there to split the water and give off the oxygen. Am I right? And the hydrogen is kept and get taken by the carrier called NADP, right? We also do not forget in your answer to make ATP. So what I'm going to do is I'm going to reveal the answer, yeah, so that we can go through it. And I'll go through it with you quite nice and easily, right? Let's use pink. First of all, what was that boy's name?
Mukov. With the NADPH.
With a grana.
Grana.
With a grana.
I think it was a girl, hey?
Was it a girl?
Okay, let's look for grana.
Let's
With
check.
grana.
Grana. The
No,
one
it's
happens
fine.
in the grana. So the light phase happens on the grana. And the dark phase happens, where is it?
Stroma.
On the stroma. I'm just trying to find it. Which content? Chlorophyll and the light. That's fine. Light is absorbed. Well, I suppose we'll get done there. Light is absorbed, very nice, and changed into chemical potential energy, which is ATP.
Tshegofatso.
Yes.
It's a guy.
See?
Sorry.
Yeah. Don't listen to her.
No.
Right.
No.
Right. Now, there we go. So, it goes into chemical energy, okay? And it creates a thing called ATP. Very important. The other thing that it does is it breaks water molecule down, right, into hydrogen or two hydrogens and an oxygen. And the oxygen is given off and the hydrogen is put with a thing called the NADPH2, which is the carrier. NAD, whoa, no, don't do that. NAD, there we go, let's erase that. There. NAD is the carrier, so NAD, oh, that's P, DP. NADP is the carrier, and the hydrogen from the water molecule makes it NADPH2. Yeah. Okay, cool. So that comes along, and that all goes through to the dark phase. Right, we all happy with that? You all understand that? The dark phase, as he said, happens on the stroma. Very, very nice. Do you know how many people forget about that, hey? Very important. People forget that on the chloroplast, one happens in the stroma and one happens on the grana. Very important to remember that, hey? Then, let's see. The chloroplast, or CO2, well, it happens in the chloroplast, in the stroma, right? CO2 from the air comes in through the stomata. This is where we start using carbon dioxide. Did we use carbon dioxide in the first place? No, we didn't. We used water and we used sunlight. Okay, now in the dark phase, we use this thing called carbon dioxide, right? Which goes through, comes through the stomata, right? Then it takes the NADPH, it gives out the hydrogen molecule, right? So it takes the hydrogen molecule away, that energy that is around. That's very important. It needs that energy between the bond between the hydrogen and the phosphate, NADPH. Right, very, very important. The ATP provides the energy needed for the reaction. Okay? It needs that reaction. It needs that energy. The ATP builds it up. Very important. And at the end, we produce this C6H12O6 molecule called what, Looney? See, I knew it.
C6 what?
C6H12O6. Think about energy. Think about...
CO2 is reduced to...
No, forget about that. This is not on there. This is just something for you to tell me about. Yeah, it's this C6H12O6.
Think about
What is that
energy.
stuff? Yes, energy. How do you get energy? You got to eat some... Yeah. What is that stuff?
Sugar.
It's the same stuff that you... Not really, but I'm going to give her a clue. Same as L. Not
Alcohol.
L, as in A-L. But anyway, okay? It's the same as that. So, glue.
I said sugar. Glucose.
That's the one. It's not sugar.
Not sugar.
It's glucose.
It's close enough.
It's not. It's glucose.
Close enough.
Glucose. Tell her it's glucose. It's not sugar.
Close, man.
Right.
You should have said when I said sugar, you should have said, no, there's
Now,
a
this is glucose.
glucose. C6H12.
Very important. Right. Good. Hey, she got the answer right. I'm moving on. Right. That is very important. So that is what I want from you guys. Okay. It's a nice, simple, easy explanation, but everything is there. Don't forget, I'm looking for stroma. I'm looking for grana. I'm looking for water. Gets split by the light. NAD picks up the hydrogen, so it becomes NADPH2. That goes to the dark phase. The oxygen gets given off, and that energy that's made from that is made into ATP. ATP comes down to the dark phase. The hydrogen joins with the carbon dioxide, or CO2, that comes in. The C, the O, and the hydrogen, there it is. The C from the carbon dioxide, the O from the carbon dioxide, and the H from that water splitting in the beginning, or from the NADPH2, that there makes the nice big glucose molecule. Right, so all of that is very, very, very important. Hey, Looney, you learned something.
Yes, I did. I did.
Good, I'm glad. Now, what I'm going to do is, I got another question here for you. Let's go through it. Let's see. Does anybody have questions for me?
Mm-hmm.
Okay, well, let's do the questions for them first.
From Vicky, what is the difference between grana and granum?
Grana is one, granum is a few of them.
Oh. This is Luzuko. Does the leaf lose chlorophyll when it's taken away from the tree immediately? If no, when does the leaf lose chlorophyll?
Okay, so chlorophyll is found inside the chloroplast. So what happens is it actually leaves the thing. So it doesn't like, okay, I'm picked, I'm gone. Okay, I picked that leaf. Can you remember the leaf that I put in there in the beginning? It was very green. I picked that this morning. Okay, so it's lasted a whole day just in a dark spot. In a dark spot, it's lasted the whole day and it was still green. Okay, I needed to take, and you saw me when I put into that alcohol, it got rid of the chloroplast, or the chlorophyll, should I say, and the color of that liquid changed. Can you remember that? Right? So it lasts for a long time. If it look at when it comes to autumn, okay, and you start getting those brown leaves, the chlorophyll has been removed out of those leaves because it's gonna lose. We're gonna lose the leaves. It doesn't need them. It's got enough stored energy everywhere else, and the leaves will fall out and die. And that's why they become crunchy and different colors. They've removed the chlorophyll out of them. Hey, Looney, you think that's answering it?
Yes, that's cool.
Good.
From Beauty, does photosynthesis take place in green stems, and do green stems contain chloroplast?
They do. That's very nice. They do. Like, for example, a cactus. Hey, cactus has beautiful leaves, hey? Those big, beautiful leaves with thorns on it. Hey, Looney.
Cactus, yes, thorns. I know what you're talking about.
Nothing. Hey, you with me here? Right? I'm glad that you can hear me, right? Because Looney knows nothing. Cactus. The little thorns are the leaves, right? And the stem is that big green thing that looks like a leaf. Hey, Looney, did you hear me? Right? That is a stem and it goes through photosynthesis. Hey, Looney? So stems do it. Yes. Very, very good. Stems do it. Yes.
Okay, in practical one, what happens to the chloroplast? Where does it go? Does it stay in the alcohol?
Yes, it does. I mean, if you stay... Oh, it's a bit far. Let me try. Right. Let me stretch over and get it. There it is. Okay? This is where the alcohol, the chloroplast has gone. Now, if I used ethanol, which is see-through, it would go green. It's actually gone a bit green. Okay? Hey, Luni, it's a bit green. What do you think?
A darkish.
A very dark green. Huh? But remember, there was purple with it, right? It had that purple liquid with it. Okay? Now, that is very important. It pulls it out. You understand?
Yeah.
Huh?
Apparently we have 50 seconds, so it's over. It's done.
It's
Glad.
done.
Gone.
You're going to miss me. Huh?
Yeah, time flies. Hey, at 5, it goes, it goes, gone. But yeah, thanks
But
anyway.
it's a whole week.
Yeah,
Till
I
see
know.
you again.
Yeah, very long. But yeah, thank you for the lesson. Thank you guys at home for tuning in. Thank you for enjoying. I know you guys enjoyed it because you said on Facebook. Shout out to all you guys. I can't say all your names because we're running out of time. But we love you so much, guys. We adore you.
smile.
We love you very much. Thank you so much for tuning in, guys. Until next time.
Miss you lots. Cheers.
Yes. Bye, guys.